Hello guys, welcome to the Innovation Lab. So as I was designing our new 5000 watt DC to DC boost converter board, I actually found a way that we can boost the output power of these DC to DC boost converter modules, especially at low input voltages. And as you guys know, that has been a problem for most of us because as we know, these converters are rated at 1800 watts, and you can only get close to that value if you're using the maximum input voltage, which is right around 60 volts. So that makes it challenging for most of us who really all we want to do is to apply an input voltage level of about 12 to 24 volts and use it to drive up our system to about 48 volts or higher. So that means you have this massive limitation. At 12 volts, you can only get about 300 watts out of this unit. So this really is amazing because it could help us solve that problem. So and I'm going to be making an actual video to explain everything that we have done, and I'm going to provide you guys with schematics. But for this video, I am really super excited. I just wanted to make this quick unofficial video to share this test with you guys. We have tested the unit at 12 volts and we were able to get up to above 500 watts. I don't remember the exact number. I think it's close to 600 watts. And we also tested it at 24 volts and we were able to get up to 1000 watts at the output of this converter at 24 volts. That's very impressive. So this is the first time that we're testing it at 36 volts. So I wanted to make a quick video to kind of conduct this test with you guys so that you guys can share in the fun. Again, this is not going to be our official video where we kind of explain everything and make it all nice and everything. So I just want to try this format. I hope you guys like it. And if you guys would like to see more of what we did, we are going to be showing that in a future video. But in a nutshell, as you guys can see here, I had to redesign the power inductor to kind of make it stronger and more efficient at higher frequencies. So we looked at critical inductance, we looked at skin effect, and a bunch of other calculations that we had to do. We also had to increase the output current sense shunt. Also, we made some modifications to allow us to dial down the switching frequency of the converter to about, as you guys can see here, about 22 kilohertz from the limit that he had on these guys, which I think these guys have a switching frequency of close to 100 kilohertz. I think the success that we are having here revolves around the new inductor design. This is the inductor that came with the unit, and it kind of makes sense that they use cheaper inductors because if not, you can't buy this unit for like $25 to $30. This inductor build is quite expensive, but it's giving us very good results, very good efficiencies. All right, guys, let's go ahead and check this out. And so we're gonna run it at an input voltage of 36 volts. And my goal is really to see if we can exceed 1500 watts at the output, and that will be amazing. All right, guys, let's jump into it. All right, guys, the system is already up and running, as you guys can see. We have our 36 volt power supply, and this power supply is capable of giving us more than 2000 watts of input power. And we have our modified DC to DC boost converter. So right now we are taking in an input current of 8.47 amps at 36.7 volts going into the converter. We boosted it up a little bit, and as you guys can see there, so right now we have a load of 282 watts at an output current of 7.52, input voltage or output voltage rather of 37.6. And for our load, we're going to be using these two 1000 watt heaters. So both of them are connected in series to allow us to drive high output voltages into the system. So technically they can give us up to 2000 watts. All right, so let's go ahead and slowly raise the output voltage of the system. And given that we have constant resistance load, give or take, it might drift a little bit as the heaters get hot. So by Ohm's law, if we increase the voltage across the load, then the power will increase. So that's how we're going to be implementing kind of the load stepping of the test that we're about to do. All right, but before we get started, I'm going to connect the fan, to help cool the system with all the loads that we're going to be putting on it. All right, guys, we have connected the fan. So now let's go ahead and increase the output voltage slowly. All right, and as we do that, we keep an eye on the output power monitor. All right, we have just crossed 1000 watts. All right, guys, as you guys can see, we are now at 1.52 kilowatts with an output current of 17.3 amps going to our load, an output voltage of 87.4. This is quite amazing. So let's look at what we're measuring over here. We have an input voltage of 36 volts and an input current of 49.2 amps. So when we do the math, we can kind of see the efficiency of this system with this much load. But this is quite impressive. So the thing to note here is that without the modification that we just made, if we apply the same input power to this DC to DC boost converter, which is 36 volts, we should have been expecting about an output power level of barely 1000 watts. So this is quite impressive. As you guys can see, the output remains stable. And over here, you guys can see our heaters boiling away. All right, guys, this is amazing. I am happy. I am super excited. We're going to be making a video to show you guys everything and how we are able to accomplish this. Looking at the duty cycle, this tells us that we can actually exceed the 1500 watts that we have right now, but I just want to play it safe. I don't want the input fuses and the converters to blow at this point. Yeah, this is quite impressive, guys. All right, guys, that's it for the video, and I hope you guys had some fun. As you guys saw during the testing, we measured an input current level of about 48 amps at an input voltage of about 36 volts. So we put a load of about 1500 watts on at the output of the converter, and it drove it really well. So if you do the math, that gives us an efficiency of about 85 to 86%. If you ask me, given where we are coming from on these converters, I would say that's quite impressive. Actually, given the original converters that are not modified, at 36 volt input, we should have been expecting about 1000 watts of output, and that tells us that this modification works really well. And as we mentioned earlier, we have done this test at 12 volts and at 24 volts. We got really good results. All right, guys, if you like to see the full video that I'm gonna make, very detailed, to show you guys all the modifications that we have made, how we are actually able to make this possible. If you would like to see that, make sure you subscribe to the Innovation Lab so you get notified when we release that video. And we are also still working on our 5000 watt DC to DC boost converter. We have finished the board design and we're going to be receiving it in a few days. So we'll start building up the board, installing all the components, and we're going to be able to test also very soon. All right, guys, if you'd like to see all of this, don't forget to subscribe to the Innovation Lab. All right, my friends, I will see you guys in the next video.